So if you have to look for x plus a to the power of 5, what you get should look like this. This gives us x to the power of 5, right? Because a to the power of 0 is what? 1. 1 times x to the power of 5 is still x to the power of 5. This thing, we can decide not to put the 1, or we decide to put the 1 plus. This gives us 5x raised to the power of 4 and then a. Because a raised to the power of 1 is still a. Plus 10x raised to the power of 3, a raised to the power of 2. Plus 10x raised to the power of 2, a raised to the power of 3. Plus 5x a raised to the power of 4 plus a raised to the power of 5. So your final answer for x plus a to the power of 5. Normally, the primary school or secondary school style, they told us this. If you want to find this, you say x plus a times x plus a times x plus a times x plus a, right? Times x plus a. That is, expand this 5 times. So if you do this, you will land at 1x. You should land at this rubbish that we have here. So our answer for that expansion is this stuff we're having on the board. Should in case you are given to find, let's say, x plus a to the power of 3, without doing too much calculation, look at the Pascal triangle. What do you think we should get? Plus what? 3x to the power of 2 times a to the power of 3 plus
3 raised to the power
So this should be your final answer without doing too much calculation. So first of all, just know that the first number in your expansion to the power of 3, go to your third row, you have 1, and then this first one will start from the power and reduce to 0. The second one will start from 0 and increase back to the normal power to get this. You can go and try more of that on your own. So without further ado on this, any question on this before we move ahead very quickly? Your question? For expansions that have more than 3 terms, like x plus a plus b, like this, right? To the power of something like 3. Using Pascal's triangle, you can't, because the Pascal's triangle is already, they've told you that each of the coefficients or each of the terms in your Pascal's triangle are expansions of x plus a to the power of a. That is, it can't be more than 3 terms inside. This is the format of your Pascal's triangle. You can't be more than 3. So when you have x plus a, mind you, you might have 2 plus 5 to the power of let's say 3. Now let's see if we can use Pascal's triangle to do this. 2 plus 5 to the power of 3. First of all, we go back to our third row. Our third row is 1, 3, 3, 1. So we write 1 times 2 raised to the power of what? 3 plus 3 times 2 raised to the power of what? 2 times 5 raised to the power of 1 plus 3 times 2 raised to the power of 1, 5 raised to the power of 2 plus 1 times 5 raised to the power of 3. Are you following?
Yes.
So this gives us 1 times 2 raised to the power of 3. 2 raised to the power of 3 is what? 8. 2 times 2 times 2 is 8. We have 8 plus 2 raised to the power of 2 is 4. 4 times 5 is 20. 20 times 3 is 60. Plus 5 to the power of 2 is 25. 25 times 2 is 50. 50 times 3 is 150. Plus 15 to the power of 3 is what? 15 to the power of 3 or 15 times 15 times 3 is 75. Sorry. Oh, 5 to the power of 3 is 125, right? This gives us 125 plus 150 is 275. 275 plus 60 is 235. 235 plus 80 is 340. So this gives us 7 to the power of 3, right? Normal, we would have just said 2 plus 5 is what? 2 plus 5 is what? 7. That is from this part. 7 to the power of 3. 7 times 7 is 49. 49 times 7 is what? Let's confirm this answer, please. 3 is right. 343. 343. So 7 to the power of 3 is what? 343. So see that we use binomial expansion to land at 343. Why we could have just done that earlier by saying 2 plus 5 is 7. 7 to the power of 3 will give you 343. So binomial expansion is just dealing with when you have two terms that are raised to the power of something. If you want to expand it, you can't just expand it the normal way. You have to use binomial expansion first of all to get your coefficient, and then rest of them like that. So let's go into binomial theory. Please, your question. The power as fractions. The power of fractions, we are going to use binomial theorem to deal with that. Because this is the limitation of Pascal's triangle. Pascal's triangle, the limitation of Pascal's triangle is that when you have power as a fraction, let's say your power is 1 over 2 or 2 over 5, you can't just use Pascal's triangle to get that. Because each of these, this is the 0 row, this is the first row, this is the second row. But this one is dealing with the 1 over 2 row, which is not in your Pascal's triangle. So binomial expansion is used to find stuffs that your Pascal's triangle is limited to finding. Are we following? So let me run this off. So this video will be available on YouTube for everyone of us seated here to watch. In case you came late too, you could just use that as a video.
How about if it's a decimal? Decimal number.
If your power is decimal, it's the same thing as if your power is fraction. Fractions are numbers that could also be written in decimal form, right? 1 over 2 is the same thing as 0.5. So you could decide to put it in fraction or decimal. So we are moving here, please. Let's just give it what you have to do. So our binomial theorem now. Binomial theorem or binomial expansion. A binomial expansion is on the previous subtopic. Which is, please be fast with that.
Like, here's when you have x minus a. Like, you know, this
Minus is always following that number. If you have x minus a, let's say to the power of 2. If x is to the power of 2 here, the second part where x is to the power of 1 minus a will be to the power of 1. That minus will follow it. Are you following? As if you have plus, all you need to know is that minus will follow that number when you are carrying it to the power of something. You understand? If you don't understand, you tell me or you check after the class. So we have binomial theorem. A binomial theorem is given as if we have x plus a x plus a to the power of n is equals to x to the power of n plus n. Let me confirm that very quickly. Okay, and then nx divided by 1 factorial plus n into n minus 1. This is over 2 factorial, and then x to the power of n. This is n minus 1, n minus 2, and then a to the power of a to the power of 1, and this is a to the power of 2. So it keeps going on and on like that. So this binomial expansion is used so that you can find out when you have powers that are fractions. The reason why this is best used as the binomial expansion is that if you decide to use the very basic one, for those people that did further maths in secondary school, they must have told you nc0 x to the power of n a to the power of 0 plus nc1 x to the power of n minus 1 a to the power of 1, and then plus nc2 x to the power of n minus 2 a to the power of 2. So this must have been the way, this should have been the way we would have written it. But when you have your power as fraction, if you want to find combination of a fraction, let's say our power is fraction, is a fraction 1 over 5. So 1 over 5 combination 0. 1 over 5 factorial over 1 over 5 minus 0 factorial times 0 factorial. This doesn't make sense. In math, this is rubbish. Because you can't just find combination of a fraction just like that. Because combination is dealing with counting numbers or natural numbers. So this is not a counting number. I can't be counting and say this is 1 over 5, 2 over 5. It's not correct. So you can best use this as your binomial theorem. Mind you, this stuff continues to infinity. That's why I ended with 3 dots. Your expansion, you could decide to end it as n times n minus 1, because the next term here should be n times n minus 1, n minus 2 times n to the power of n minus 3, a to the power of 3 over 3 factorial. But without writing all this much, the highest I've seen, I think the highest I've seen in a question, probably exam question or a test question, and even the questions, especially all the questions we saw in this book, they will tell you find the binomial expansion to the third term. This is your first term, this is your second term, this is your third term, that's all. Except they say to the fourth term, which seems to be very rare, then you add this one. This is your first, your second, your third, your fourth. If they say fifth, you continue again, keep going like that. But just use this as your basic binomial expansion. Now to find, let's say, x plus y to the power of 2. This is equals to, or to the power of, okay, let's do 2 first before we go to fraction. This is x, we said this first one is to the power of this one, f to the power of 2 plus, that power now 2 times our x to the power of 2 minus 1 times our a, which is our second term in this bracket, y to the power of 1 plus our n is our power, which is 2 times 2 minus 1 times x to the power of 2 minus 2, and then a to the power of 2 all over 2 factorial. This gives us x squared plus 2xy plus 2 factorial is the same thing as 2 times 1, Abi? So 2 times 1 is 2, 2 cancels 2. We are left with 1 here, 2 minus 1 is 1. So this gives us x to the power of 0 times a squared. X to the power of 0 is what? 1. Because x to the power of 2 minus 2 is x to the power of 0. X to the power of 0 is 1. So this gives us 1a squared, which is our final answer. In your Pascal triangle told you that in that second row you have 1, 2, 1, right? The first row is 1, 1. The zero row is 1. So this is your 0 row, your first row, and your second row. So your second row, the coefficient is 1, 2, 1, which is what we have here. There is an invisible one here and an invisible one, which is 1, 2, and 1. So you see that binomial expansion is just another way of solving something that could be done with Pascal's triangle. But the limitations of Pascal's triangle is that you cannot use it to find when your power is a fraction. So let's say we have x plus y to the power of 1 over 2. We will go straight to this part. You see x to the power of half plus our power now. I'm using this expansion plus our power, which is n. Our n is 1 over 2. X to the power of 1 over 2 minus 1. And then our a is y to the power of 1 plus we have n, which is our power 1 over 2 times 1 over 2 minus 1. X to the power of 1 over 2 minus 2. And then a to the power of 2. All over 2 factorial plus dot dot dot. If you say you want to get to the end of this expansion, it might not be possible because if you have about infinite terms, infinite number of terms, or infinite means something that doesn't have an end. I like to see what it's like this. If they say find the end of this stuff, it just keeps going around like this.
Why did you see represented as a instead of y?
It's a mistake, an error. So this y to the power of 2, this y here. So x to the power of half can also be written as what? X to the power of half can be written as what? Square root of x. So if I say 4 to the power of half, our answer is what? 2. Because this 2 will become square root of 4 to the power of 1, which is this one here. And this is equals to 2. Square root of 4 is 2. So x to the power of half can be written as square root of x, or in your question, in your options, they might leave it as x to the power of half. This gives us plus 1 over 2 times everything here, x and y. We multiply 1. It means we are dividing by 2. These 2 here. X to the power of half minus 1. Half minus 1 is what? Minus half, right? And then y to the power of 1 plus half times half minus 1 is minus half, all over 2 factorial. Half minus 2 is what? Minus 3 over 2. Okay, you have 1 over 2 minus 2 now. Half minus 2, your LCM is what? 2. 2 divided by 2 is what? 1. 1 times 1 is 1. You have minus 2 times 2 is what? 4. This gives you minus 3 over 2. So half minus 2 is minus 3 over 2. And then we have y squared. It gives us plus. So from here we can have our answer as x to the power of minus half. If you have an index that is a negative number or a power that is a negative number, the minus means that if this minus can be written as 1 divided by, the minus has become 1 divided by x to the power, please do have that, x to the power of half. So this minus became 1 divided by, but we are multiplying this x to the power of minus half, which is this, by 1 over 2, sorry, by y. So this gives us times y times 1 over 2. That is this one, this 2. I can try to write it as 1 divided by 2. So we have 1 over 2. First of all, 1 times y times 1 is y, all over x to the power of half is square root of x. And then 2 times square root of x is 2 times square root of x. So this gives us y over 2 root x plus half times minus half is minus 1 over 4. X to the power of minus 3 over 2 times y squared. And then we are dividing by what? 2 factorial, right? We are dividing by 2 factorial. First of all, this minus becomes, the minus becomes 1 divided by x to the power of 3 over 2. X to the power of 3 over 2 can be written as what? Any idea, anybody?
Square root of x raised to the power of 3.
Square root of x raised to the power of 3. That is, this denominator here, the 2 becomes square root. And then the number that is on top in fraction, which is 3, will be the power. Are you following? If you have x raised to the power of 5 over 2, it's the same thing as square root of x to the power of 5. Even if the denominator is, let's say 3, let's say 5 over 3, this means cube root, or the third root of x to the power of 5. So back to what we were doing earlier, we said x to the power of 3 over 2 is the same thing as square root of x raised to the power of 3. Okay, first of all, times y squared times divided. When this division changes to times, we have 1 over what? 2. This is equals to y squared times 1 is y squared, right? Like minus 1 times 1 is minus 1. Minus 1 times y squared is minus y squared. Times 1 is still minus y squared. 4 times 2 is what? 8. X to the power of 3 over 2 is the same thing as third root of x, square root of x to the power of 3. So this stuff might seem very ambiguous or too crude for you to do. So it's left to you to go and refine it. The only way you learn maths is when you do it on your own. I'm just here to guide you, to give you a guide or give you an edge whenever you are studying on your own to understand it. So this can be written as minus y squared over 8 root x to the power of 3. This part now we solve it as this is minus y squared over 8 root x to the power of 3 plus dot dot dot. So if they say find the expansion of x plus y to the power of half, your answer should appear like this. Except they don't want to put square roots, they will now decide to say x to the power of half plus y over 2x to the power of half minus y squared over 8x to the power of 3 over 2 plus dot dot dot. All of them is still the same thing, just different expressions of one thing. So your options will be might either come out this way or this way. So you just have to practice. That's why we created this Solve Easy Solutions manual. It has the 4 years past questions and answers in that manual. And it also has the textbook part, your Maths 101 textbook. All the exercises were solved there. So you see exercises on binomial expansion in that book. We did many of them. And there's also a physics 101 part there. For those people who are physics 101. Physics 101 3 years past questions and answers is also there. We also have physics 103, which is different from this. But this one goes for 1,000 naira. So, for those people that might be interested in the private tutorial, because many people have been asking actually for private classes, being that the tests and exams are approaching. So you meet me after the class, then we converse. Okay, I shouldn't explain this. Then we converse after the class on what to do for the private tutorial. We are here to make a video on this on our YouTube, so that's why I'm videoing this class. So for those people that have a smartphone that can go on YouTube, check Solve Easy channel. Make sure you put channel so that you can easily find it. You see the logo as a tree, blue tree, and then you see Solve Easy white and blue logo. So you find this video of this class there. One studying the binomial theorem. So any question before I round off? Or any question on any other topic in your Maths 101? Let's deal with it. Sequence and series. Wow. Okay, give me just one question on sequence and series. And then if you have any question, prepare it. What's your question? You don't have a question? Mathematical induction. Wow, that's very nice. So what's your question on mathematical induction? Do you have any question there? Yeah, so it's a question. You don't have any question? What's your question? So in this book we have about 15 to 20 15 to 20 mathematical induction questions there. and I will solve them. So what's your question? Which mathematical induction question do you have from your textbook, from anywhere, or past question? Plus dot 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 plus n
equals to n bracket n plus 1 n divided by 2.
Now, for mathematical induction, for those people that have attended the class, how many steps are there in mathematical induction? How many steps do we have in mathematical induction? 2. We have 2 steps. This exactly how I said it is how the question might come out. Exactly. Questions come out on how many steps do you have. The reason is, in mathematical induction, first of all, assume P of n is true when n is equals to 1. The second one is assume P of k, P of k plus 1 is true. So many people would say this is 1, this is 2, and this is 3. But this P of k and P of k plus 1 are just one step. Now to prove this, we want to prove it by mathematical induction. First of all, we are dealing with the variable part. Variable is the thing that might change. N could be 1, could be 2, could be 3. So first of all, we said assume P of n is true. P of 1, P of n when n is equals to 1. This is P of 1 implies that we have 1 on this part. 1 is equals to 1. That is for n we put 1. For n we also put 1 plus we have 1 all over 2. This gives us, in this part we have 1. This is equals to 1 times 2 all over 2. 2 divided by 2 is what? 1. So 1 is equals to 1. So the first step is to prove that, to assume that P of n is true when n is equals to 1. So if your left hand side and your right hand side are the same, you can go on with your proof. But if they are not the same, just like that stuff they ask you to prove is actually wrong. Or you made a mistake on the way. You just listen to me. So now we also have P of k is true. For P of k, it means wherever there is a variable n, you put k. Our left hand side tells us k. While our right hand side tells us k into k plus 1 all over 2. Right? We change n to k. But P of k plus 1, P of k plus 1 such implies or such that the left hand side is equals to wherever there is n, we put k plus 1. K plus 1. Now P of k plus 1 again for the right hand side, wherever there is k, n, we put k plus 1. We have k plus 1 times wherever there is n, we put k plus 1. But apart from this n, we also have a plus 1 there. We have plus 1 all over 2. Now looking at this very well, this is equals to k plus 1 times k plus 2 all over 2. The reason why these two are on the same line, or the reason why they are the same proof or the same step, is that looking at the left hand side, it looks like we added 1 to k, right? It looks like we added 1 to k. So if we added 1 to k on the left hand side, let us add 1 to k on the right hand side. Are you following? That is, this line is like you just added 1 to this k. But let us see whether if we add 1 to this side again, we can end on this kind of stuff. Now you add 1 to the right hand side, you say to the right hand side of P of k, add 1. We have, this implies k into k plus 1 over 2 plus 1. Our LCM is what? 2. 2 divided by 2 is 1. 1 times k times k plus 1 is k times k plus 1. And then plus 2 times 1 gives us 2, right? So we are trying to find it out if we can land in this kind of stuff. This gives us k squared. K times k is k squared. K times 1 is plus k. And then plus 2 all over 2. We have many of these on our YouTube page. You can check there. Now we are trying to land that answer there. I guess I could print this because this was the first of the day. From quadratic equation, we have k squared plus k plus 2. How can we express this using quadratic equation steps or using factorization? We have k here. We are looking for two things that when we multiply them by themselves, we will get a positive k. Or let's look at what when we added 2 to when we added 1 to k into k plus 1 times k plus 1 over 2. How can we express it to look like something like this? The only way we could do that is by saying this gives us k squared plus 1 2k minus k plus 2. This is actually wrong because it will be impossible. 2k minus k will give you k. We agree that k squared plus k plus 2. But 2 times minus 1 can't give you a negative, can't give you a positive 2. So the only way we could express this is by saying k times k is k squared, k times 2 is plus 2k, 1 times k is k, 1 times 2 is 2, all over 2. This gives us k squared plus 3k plus 2 all over 2. Now this can be expressed as k squared plus. Now if we look at this using factorization, is there any two things that when we multiply them we get 2, and any two things that when we add them we get 3? I guess it's 2 plus 1. This is k squared plus 2k plus k plus 2 all over 2. This gives us k into k plus 2 plus k plus 2 or 1. So we have this has led us back to what we had earlier as k plus 1 times k plus 2 all over 2. So the main thing we should do is, so write down that book.